All right, folks, good morning. Happy Monday. Okay, I hope you all had a pretty fantastic weekend after the first week of school. Welcome to week number 2, and we are getting into it. All right, so today we're talking about lesson 6, describing transformations. The goal of this the goal of this lesson is to be able to, we want to be able to apply transformations to a polygon on a grid. Okay. So kind of similar to what we did Friday, but we're getting a little more practice with not only performing the transformations or the sequence of transformations, but also getting familiar with what information we need to know in order to perform these transformations, but also what information we need to give to people if we want them to perform a transformation. Okay? That's what this lesson is going to focus on. All right, there's one activity, there's a lesson summary, so we've got plenty of time to go over that homework, okay? I do want Charles to spend a good bit of time, well, not a good bit of time, take like 5 minutes to check out this starter. Finding a center of rotation. It is on page 47, okay? It says Andre performs a 90-degree counterclockwise rotation of polygon P and gets polygon P prime. But he does not say what the center of rotation is. Can you find the center of rotation? That's kind of the idea. All right, so go ahead and pause this video. Take about, however long you need to find the center of rotation. But make sure, right, that center of rotation has to be the same distance from all points. That's in P, polygon P, and polygon P prime. Okay? Go ahead and pause the video. Give it a shot. Whew. All right. So if you're here, you're probably yawning because I yawned, and that stuff's contagious. Or, well, yeah, you've probably done the starter. So check this out. Okay. What does he not say? So what does he say the center of rotation is? We don't know. Andre sped through it, didn't write his center of rotation. Can you believe the nerve of some people? Oof. So here's how I did it. Okay. I'm looking for a point that is the same distance from each vertice. Okay, so we know it's a 90-degree counterclockwise rotation. So this is rotating this way. Okay, so we want to find something that's the same distance from all the corresponding points, right? This point here is 1 up and over from this point. Its corresponding point is up and over. All right, that looks nice. But if we rotate that 90 degrees, rotate that 90 degrees, it should be there. Okay, so that's not going to work. Our new line doesn't really line up with that. Okay, that's not quite it. I mean, also, if we put the point here, check this, or if we put the point, let's say up here, right? If we rotated around that point, this shape would probably end up somewhere in this area. Okay, so that doesn't make much sense. Really, how I do this is I'm doing a process of elimination right now. I am picking points and testing if they're going to work. I'm not going to pick this point because it's only 1 unit away from here, but it's clearly more than 1 unit away from the other one. So let's try moving it over 1. Okay, here. It is 2 points from there, 2 points from there. That looks nice. That's 90 degrees already. Looking strong. Okay, so to get to here, we can do that. A very similar thing too. And this polygon, this rectangle here, if we rotated it 90 degrees counterclockwise, we would also get this rectangle. Okay, things are looking pretty promising. Let's give it a go. Okay, so notice how I'm drawing on here, right? If you draw onto a shape, like if our center of rotation isn't connected to our shape, you could draw an extra part of that shape onto it, and that might help you figure out where the center of rotation is. Okay, here, if I'm keeping my center right here, I'm going to put it in a different color because this is hard to see. I don't know if any of y'all are colorblind yet, so we'll do blue. Okay, right in the middle there. That's our center of rotation. Okay, so if I was to rotate this shape 90 degrees, about that. Okay, let's see where it would go. So key thing as well, right? here we've got a 90-degree shape right there. That's our 90-degree angle. We want that box to kind of rotate 90 degrees. So I'm going to put a little mark. Let me show you. I'm putting a little mark on the top. Okay. Just so when that little mark is flat, because it's a vertical mark, right? If it's flat, I know I've got 90 degrees. Okay, let's try that. All right, we're going around. Actually, what do I want to do? I want to do this. Okay, it's flat and it's in the right spot. So that's a 90-degree rotation. And that is our center of rotation right there. So let me erase all this good notes that I've taken. Okay, that will be the center of rotation. If you got that, fantastic. If not, it's okay. Finding a center of rotation takes practice. And there are other tools and strategies you can do to find it. Okay, not bad. All right, so I do want to take this time now. We didn't go over 1.4, the practice problems for 1.4 on Friday because it was a short day. So we're going to go over those practice problems now. Oh, not there. I don't want that one. There it is. Okay, so if you have completed your first attempt of those practice problems, go ahead and pull it up. You can work on a second attempt while I'm going through this video, or you can work on those problems again while I'm going through it. All right, so it says here for each, and the practice problems in the workbook start on page 34, okay? So for each pair of polygons, describe a sequence of translations, rotations, as reflections that take polygon P to polygon Q. Okay, great. So I've kind of done part of this. I've kind of wrecked this for y'all. A sequence. So we've got this isometric grid. So we'll probably want to use some 60-degree rotations, right? Okay, and you can see here, this is, if we look at this shape P, right, it's not in line with Q. So, oh, that's neat that lines up. Okay, so we will have to be doing a rotation here. It's oriented the same way, right? Well, a different way, but it's not inverted, so there's no reflection here, and that's good news, okay? So there's so many ways to get polygon Q or polygon P to polygon Q, a ton of ways, okay? I'm going to show you one of the ways I did it, all right? But if you took different steps and got to the same place, congratulations. There's so many ways to do this, okay? And I think actually on Canvas, it gives you a very specific way to do it. Like it has options, right? I think the option was take A to H was the correct option, and then do a, what was it? It's a 60-degree. Oh, I should probably write this down. So transformation in a different blue, because that one is hard to see. Okay, so we're doing a transformation, right? We're transforming so that A goes to H. Great descriptive. It's figured out. Ignore the fingers on the side of the page, by the way. It's how you gotta do. That's how you gotta copy it sometimes, I guess. Okay. So A goes to H. We've got that much down. All right, and that's a great way to. I'm gonna move it there. So a great way to get it started. Now we know that H is probably our center of rotation, right? So the next is going to be a rotation. Because we have to rotate it into place now, right? I'm going to say center H because I don't want H to move, right? That isn't a good spot. It's already connected, okay? I'm going to go clockwise this direction because I feel like I'll get there quicker. So we'll go clockwise. And we'll also say, how far is it? Well, remember, to figure out the distance of a rotation, you should probably measure the angle between two corresponding side lengths. You see how these side lengths are the same on both shapes, right? They're in the same spot. And the angle measure between those, what is that angle measure? The angle of an equilateral triangle, or the angle between the grid of an isometric grid. If you said 60 degrees, you're absolutely right. Okay, that has to be 60 degrees because, as you see, it's the same angles as the equilateral triangle. Okay, so I'm going to say counterclockwise by 60 degrees, and that will totally take you from P to Q. Okay, good work there. Let's move on to part B. Okay, this one, We're going from P to Q again. Now, again, I've already kind of given a little bit away here. All right, again, a very specific question. It's wanting a specific answer. But like I said, there's so many ways to get P to Q. So many ways. All right, if you saw that, you probably, oh, I want to do that. Oh, wow, this is crazy. I don't want to do any of that. That's neat. These iPad features just get so cool. Okay, anyway, so here, the first thing, right? We do want to orient this shape the same way. And if I trace this right here, right, I'm looking to see if I can orient this shape here without picking it up off the paper. And there's no way to do that. I can't get it to fit, so there's going to need to be a reflection here. We're going to have to invert the shape. Okay, you can invert it a number of ways and still get it to Q, but the simplest way is to invert it or reflect it across the line AE. Why is that so simple? Well, if you do that, you're pretty much just right there. Okay, you're already a bit of a ways. You will probably have to do a rotation, but at least you're part of the way there. Okay, so if you do that, right, then you've got to translate it and rotate it, which is a bit of work, but that's okay. If we just rotate it so that A goes to F, right, we get this. Or actually, I'm not going to do that. I'll do this. A goes to F. Ooh. Yes, A goes to F. That's what we like to see. Okay, and after that, it's going to be a, so I should have been writing this down, but we're reflecting, right? Reflect, let's see. Reflect AE or reflect P across line AE. It's a great first step. And then what did we do? Well, we translated A to F. And then can you guess what we're going to do next? If you said, let me label these. If you said rotate, awesome. We are going to rotate. And we're going to we want this line here to end up here, right? How many degrees is that? Well, it's 60 degrees, right? So we're rotating 60 degrees. What direction was that? That was here. If we look up at the clock, that is counterclockwise. Oh, no, that's clockwise. It's clockwise. So 60 degrees clockwise and around F. So F is our center of rotation. And if we do that, right, keep F in the same place, I mean, it's a little uneven, but that's because the paper's uneven. It's not me. Lord knows it's not me. Okay? That's pretty darn close, but that will be the correct set of moves to take. All right? So not bad, folks. Not bad at all. Let's check this out. Actually, I do want to check out something right now because I want to make sure I'm giving y'all the right answer here because this one is kind of funky. Let's edit. Yeah, do that. Show me what it is. Show me what it is. Okay, that one. Let's see what it is. What does it end up being? So it was polygon ABCDE is reflected over line AE. A is then translated to F, and a rotation of 60 degrees clockwise with center F is applied. Yeah, so that's the right answer on that one. Whoop, whoop. Yeah, I got it. I got it. Yeah. All right, sweet. So that's how we perform that transformation. Okay? Or that sequence, I should say. All right, let's get this stuff. Let's get rid of this stuff. Get out of here. I guess I could just do this later. Meh. No, don't save it. My stickers. No, I don't want to do that. I want stickers. I want out. That was close. All right, so again, we're doing polygon P to polygon Q. Okay. Now, there's a few ways to do this one as well, but I'll show you kind of one of the easier ways. All right, so my. I'm showing you all how to do this. I'm going to leave this here for now. Okay? Just going to leave that there. I'm going to make a new, actually, you know what? I'm not going to leave you there. I want you to go away. Go over there. Stay there. Ignore that triangle for a second. Okay, I'm going to trace triangle P just so we get an idea of what we're doing, just so you can see what we're doing here, what I'm doing. Okay, so polygon P, if we translate P so that B is on F, makes a cool looking shape right there, right? Also, it's lined up really nicely for a reflection across line FD. If we reflect it across that line, that's going to get this point to go onto E, exactly where we want it to go, because it's got to go right across the line of reflection at a 90-degree angle and across the other side the same distance. As we can see, that'll line it up really well. And if we do that, that's when we get this shape right here. Fantastic. Oh, that's so good. So for this one, just remember, right, we translated. This was nice because it only had two moves, right? We translate B to F, and then we reflected across line FD. Ta-da! We got it. All right, not so bad. Not so bad at all. Okay? All right, let's get this stuff out of here. Oop. Nice. Let's go on to the next question, okay? 2, here's quadrilateral ABCD and line L. Okay, interesting. Right, we might have to do, well, what might we have to do? I lost my train of thought there. Okay, so it tells us to draw the image of quadrilateral C, ABCD after reflecting across line L. Now remember, this question was in your workbook, right? It's in your workbook. So we can do that thing where if we're not quite sure, we can rotate it a bit and see what we end up getting, right? We can see, okay, does it look symmetrical? All right, so let's give that a go. I mean, the way I do this every time, especially because there's no grid, I try to go perpendicular to the line and the same distance across. And that's for every point, right? Same with D. That looks perpendicular, looks about the same way across. Same with A, although it's, oh, A don't interact with C. And this might be a little off, but it's, oh my gosh, no. Okay, anyway, we're going across line C, so we can't see it. All right, once you've got those lines drawn, and you can double check that they're the same distance across, I mean, just by doing this, right? Okay, so that's a little bit longer, but it's okay, I don't mind it. All right, so we'll do a line here. Oh, I'm going to do my lines in a different color. Let's do this purple. This purple's rad. Okay, so we've got that line, that line, that line. Oh, this isn't looking too bad. Also, these colors are really cool together. Okay, so check that out, right? Again, look here, if we rotate it so that our line is vertical, our line of rotation, it looks, we can see the symmetry there, the symmetry. All right, we can see it kind of looks like it's a rocket, it's going to shoot up or something. Okay, fantastic. That's the way to do it. All right. Now, I don't know that you could draw this on canvas. Let me see what the answer wanted you to do was. Do you even have this one? Ah, you were asked if it was true or not. Yeah, well, it was true. Okay, that is hold up. It was asking, here's quadrilateral ABC and line L. The second image is ABCD after rotation 90 degrees clockwise. That's false. That's definitely a reflection. This right here is a reflection because we can tell there's symmetry there when we rotate the whole page so that a line of reflection is vertical. All right. Now the next one, y'all's had to take a picture of this, of all your rotations and stuff. So I'll kind of show you what I did. All right. It's going to be messy because I'm going to put it all on this paper. I'm going to be going all over these words and stuff. All right. So the first one we'll do in purple. We'll do a 90 degrees clockwise rotation, each using center B. Okay, that's nice that they tell us it's each using center B. So 90 degrees means that I want the corresponding line segments to be 90 degrees away from each other. Oh, that snapped perfectly. Amazing. Okay, great. So let's do that. Actually, I could probably draw a line and just make sure. So we've got B here. We want it to be, we want this line segment to be at a 90 degrees. So we want it to end up where that, I'm going to just draw a green line here, where that green line is. Okay, so let's do that rotation. All right, oop, nope, that's not it. Wrong line, right? We want to go all the way till our corresponding line is 90 degrees from where it was. Great. So let's do another one. All right, can I just erase that? Oh, that was tough. All right, let's do a green one. All right, now 120 degrees clockwise. So 120 degrees here, remember it's more than 90 but less than 180, so we can kind of estimate where that is, right? Still using center B, still clockwise, so I'm going to use this line again, right? Because we already did a 90 degree one. A 180 would be if it was here, so I'm going to say 120. You know what? That's 180. It's a little above 90. I'm going to put it right here. Okay, and we're going to do this in that green color. Okay, let's see if I can get this. Oh my gosh. It just snaps so wonderfully. What? See, we only get one, folks. If it snaps great one time, it just won't snap great the other time. Oh, I lied. It snapped beautifully. It's amazing. All right, so 120 degrees. We're going to go a little bit further with our rotation. Should look something like this. Okay. Oh, man, my back is so sore. Whew. All right, fantastic. Now, if we go 30 degrees counterclockwise, we'll do this one in that blue. Okay. I'm going to use the same line, but 30 degrees is, I mean, this is 90, right? 30 is a third of 90, so I'm going to go here. I'm going to say that's where I want this line to be, and we'll see if it snaps so wonderfully. Okay, it wasn't as nice, but still pretty darn good, right? That is impressive. Okay, we rotate that, and that's right there, folks. That will be our 30-degree angle rotation. So you're going to have something that looks kind of like a, what are those things you hold up in the wind? And they spin. I can't remember what they're called. People have them in their gardens sometimes. But it looks kind of like that. I mean, with these colors, it looks super retro, super rad. Okay, but there you go. That is what your picture should end up looking like. Okay, great work. All right, so now that we've done that, and we're 20 minutes into this video, holy cow, homework takes a while to go over sometimes, especially if I'm going over every single problem. Now, in class, I won't go over every single problem. Usually I pick 2 or 3 problems that I really want to drive home, some things that I really want y'all to be good at, okay? Something I want y'all to be able to do rotations, okay? I do want y'all to be able to do reflections, and I definitely want you to be able to identify how one shape got from one place to another, or at least one sequence of transformations to get one shape to another. So if you did one of these 3 correctly, or 2 of them, great work. That's awesome. That's kind of like, that's what I really want you to be able to do at this point, okay? All right, so, that's all that stuff. We're back on lesson 5. Let's go to lesson 6, because lesson 6 is amazing. All right, so the activity today, all right, we are going through to, these are all practice problems, 6.2 transformation information. Okay, now there's a lot of instructions here that you're going to get a problem card, somebody's going to get a data card, and you're going to silently read the card, look at the information, and ask your partner for specific information. The idea here is I want you to know what information you need to give, but I feel like we can just review that by looking at this paper ourselves. Okay, so the paper you get, it's a 2-sided piece of paper. It has each of these on it. And what I'd like you to do is actually go through and perform these transformations by yourself on your own. When you've finished it, check out what your partner's got. See if you have the same thing. Okay, but I also want you to take note of the information that this data card is giving us, because this is like the perfect example of how to perform not perform a transformation, but how to inform someone on how to perform a transformation. Okay, so go ahead and take 10 minutes on this. All right, read through all the information, try to perform them on your own. Okay. All right, so, oh no, I'm yawning again. All right, so we're here again. Let's perform. If you're here at this point in the video, you saw me yawn. Great, you probably yawned. You've done it yourself, I'm assuming, at this point. So check that out. Here's how Mr. Whale is going to do it. Okay. So the information here is super useful. We've got a translation 2 units up and 3 units to the right. Okay, cool. I can do that, right? So I want pretty much to follow this pattern. We're going 2 units up and 3 units to the right. So I'm taking just A there for now. But if you remember, right, all of these points are going to move with this shape. Because in a transformation or a translation, right, especially in a translation, if one point moves, every single point is going to move that same direction and that same distance. So let's check it out. If we go up 2 over 3, why is everything snapping? Stop. Okay. That's where we'll end up. Well, maybe more like that. It's close enough. The shape's basically there. Okay, that's our first transformation, right? Fantastic. Now's the fun part. It asks us, oh, we've got no rotation. That's good. We can forget about that. Reflection over the x-axis. Now, I've made a mistake here. Okay, what I should have done was read the order of transformations first. I got really lucky. It says translation first, then reflection. If it said reflection first, then translation, I'd be in a completely different place. My transformation would not be correct. Okay, so let's do this. I'm going to do this reflection in purple. All right, so let's do this. Let's erase these pesky points. Okay. So again, we're reflecting across the x-axis, so everything is going to go across the x-axis, just doubling its distance across. So here, we're going 2 units down. We're going to go 2 units down again across the x-axis. We get there. All right, same with this point. We're going 4 units down, 4 units down again. We get there. Okay, this other coordinate here, we do 2 units down, 2 units across that line. We get here. Now, some of you might be wondering what happens with this coordinate. It can't go down. It's already in the negatives, right? Remember, it's a reflection across the x-axis. It's hard to imagine because we've been on one side of the mirror, right? But if you were to reach through a mirror, right, you wouldn't be able to see the reflection of your hand on the other side of the mirror because there's nothing to reflect, right? So this is kind of in this nowhere zone here, all right? If it's going through the mirror, remember, we're treating the reflection the same way. All right, if you're getting confused reflecting this shape, think of the points, right? The points are moving on their own. We're reflecting each point. This coordinate went here, this one went here, this one went here. If we're reflecting this green point here back across the x-axis, well, that's simple enough. We just go 2 to the line and 2 up ahead. Okay, it doesn't matter that it's reflecting in the opposite direction as the rest of the coordinates. So it's supposed to happen. Okay. Okay, so we do that. I'm going to have a coughing fit. And we get our shape, except it's a little bit off. Let me fix that. There we go. Okay, that is our shape. Okay, it has been reflected. Oh man, it looks so funky, but that is correct. Yeah. So it has been reflected across the x-axis. It's fantastic. Looks great. Okay, and if we try to match it up, we can see that it's completely opposite the other one or the other shape. So we're in the right here. Okay, great. Let's move that back to where it wanted to go. Oh, that is where it wanted to go. Fantastic. So if you did that, great work. If that's the shape you end up with, awesome. If not, try it again. See if you can get it on your own. Okay, maybe erase some stuff, right? Let's talk about this one. Ooh. Ooh. All right, so I'm going to start with this bottom one. Order of transformations. Oh, this would be trouble. Rotation first, then translation. Okay, so there's no reflection, which is great. We don't need that bit of information. And the rotation is first. So I'm going to look at that. Okay, first of all, I want to note my center of rotation is the point 0, 0, right? The origin. Okay, so we've got that. The direction of the rotation is clockwise, and we're rotating 90 degrees. So this line here, this vertical line, should be laying flat after the rotation or in the aftermath. So if I was to just rotate that line, right? And also it helps rotating segments before you rotate a whole shape. If you're not confident rotating a whole shape, just rotate the segments, right? this is going to be at a 90-degree angle. So it's going to look like this. Okay? We rotated clockwise. It's gone, the 2 up here are now here. The 3 down here are now here. And we're set. We're good there. That line has been rotated. And once you get one line down, on a shape like this, you can kind of just count the spaces or the line segments, the side lengths of M, L, K, N. Okay? And you can just follow along with that. So for example, at point L, I mean, we've got L prime here. It went just one space over to get M. Well, that is now one space up. Okay, that looks good. That's better. From N to K, this was 3 spaces, so we'll go 3 spaces up. Fantastic. And then line MN just connected those 2 lines. So let me erase this, clear it up a bit. So we have this shape. That's correct. That's a rotation of 90 degrees clockwise around the origin. Not too shabby. Okay, so we can check those off. We did that, we did that, we did that. Now the next one is to translate 1 unit left and 3 units down. Okay, so 1 unit to the left, 3 units down. I'm just going to use this point here because it's the first one I got to. Okay, let's translate this guy. 1 to the left and 1, 2, 3 units down. All right, so it should be in here. I'm going to erase that. And I'm going to try to erase that. Yes. That's what our new shape should look like. Okay, this right down here, that little guy there, that is fantastic. Okay, good work. You're an awesome shape. Okay, perfect. That's what it looks like. If that's what you did, fantastic. Okay, you should be able to perform these transformations, right? If rotations are hard, that's fine. Keep practicing. Okay, find different things that work for you. And remember, if you just rotate segments, right, instead of trying to do the whole shape, it's going to be a little bit easier. Okay, awesome. Now, let's look at that lesson 6 summary. Okay, we've done the work. Let's see what we've done. Let's see what we're looking at. I don't know if I want to erase those yet. Let's just erase them. I'm not sure I want to do that. Oh, so this lesson summary is just kind of showing us how to perform these sequences of, how to perform these sequences of transformations, but also how to write the directions to do it. So the center of rotation for a figure doesn't have to be one of the points on the figure. Good thing to know. To find a center of rotation, look for a point that is the same distance from 2 corresponding points. You will probably have to do this for a couple of different pairs of corresponding points to nail it down. That's that kind of plug and chug mentality where we're testing things out, we're plotting points, we're testing them, and we're finding out if they're correct or not. When we perform a sequence of transformations, the order of the transformations can be important. Here is triangle ABC translated up 2 units and then reflected over the x-axis, okay? So it went up 2 units, right? This is why I had that there. 1, 2, and then it was reflected across that x-axis. We can see where it got inverted. It flipped, and then it got put there, okay? Nice. So we're now end up with this, okay? Here is triangle ABC reflected over the x-axis and then translated up 2 units, okay? So this is a different transformation right now, okay? We have reflected it over the x-axis, so it looked like, so this point went here because it was 1 and then another one. This point went 3 down and then 3 more, and this point went 2 down and then 2 more. Okay. Fantastic. So we do that. That's our reflection. And then where did it go? The triangle. And then it was translated up 2 units. 1, 2. Perfect. We're all set there. Okay, triangle ABC ends up in different places when the transformations are applied in different orders. So key thing here, right? Same exact transformations, right? It was translated 2 units up, reflected over the x-axis. Reflected over the x-axis, and then translated 2 units up. Okay, do you see how if we switch up that order, it completely changes where our shape ends up? Really interesting stuff, right? Order matters, right? It's the same with cooking, right? If you boil the rice after you put beans in it, it's not going to work. Okay, that was a really bad example. Spaghetti pasta, right? You boil pasta noodles in water, you cook spaghetti sauce, you make it warm, and then you drain the noodles and you put the spaghetti sauce in the noodles, or the noodles in the spaghetti sauce. I don't know what kind of people you are, okay? Are you sauce in noodles or are you noodles on sauce? You decide. Okay, but if you were to heat up the sauce, put it in the noodles, and then boil the whole thing, that's going to kind of be gross pasta. I'm not going to lie. I mean, try it if you want, but I think that would be kind of nasty. I mean, because the sauce would like dissipate in the boiling water and the noodles would be gross. I know some people who just boil their noodles in sauce. It's one way to do it. I don't think this is a good example. I'm kind of messing this up. I think baking is better. For example, you bake a cake, you mix the ingredients, and then you bake it. If you bake the ingredients before you mix them, your cake's going to be gross. It's not going to be a cake. It's going to be like a pile of nasty stuff. All right. Anyway, my rant's over. If you are... Oh, this is a good one. I want y'all to answer this question, okay? This is a cool down, all right? Now, it says Jada applies 2 transformations to a polygon in the coordinate plane. One of the transformations is a translation as the other is a reflection. What information does Jada need to provide to communicate the transformation she has used? I actually really want y'all to do this, okay? Go ahead and write this down if you get a chance. Write it on page, let's see. What's a page number? Oh, write it down here on page 49, just under the lesson summary. Right? What you would do to describe a reflection. What information do you need for a reflection? And what information do you need for a translation? Pause the video and I'll tell you what it is after this. Okay? Do. So if you're here, congratulations. You've probably worked through the problem. Just as a heads up, let's see this. So one is a translation, whoops, and the other is a reflection. So a reflection, these are nice. We only need to know what the line of reflection is. That's all we need to know. Great bit of information. Now for a translation, all you need to know is the distance we're moving and the direction we're moving. Those 2 things are all you need for a translation, and that one thing is all you need for a reflection. So, congratulations, you've completed the video and the lesson. Now, if there's time, if you're ahead of the game, all right, way to go. But I still want you working during class. So go ahead and try out these practice problems for lesson 6. If you have time, go ahead and get started on the homework. See if you can't get it done before the end of class, okay? If you do, great. If not, no worries, okay? But remember, only use 1 attempt tonight, okay? Wait till tomorrow for me to go over it to take your second attempt. Which reminds me, I'm going to be back tomorrow. Woo! I can't wait to see you. It'll be great. I've missed you so much. I hope Mr. Andrews has been... Oh, he's great. I'm sure he's fine. Thanks, Mr. Andrews, if you're watching this. Well, if you're watching it, you're not supposed to be. You're supposed to be watching the kids. What are you doing, man? All right, so work on the practice problems if you're not done yet, or if class isn't finished yet, the warning bell hasn't rung. Thanks for watching. Thanks for being patient with the videos and with me being gone the first week. Ugh. But anyway, looking forward to seeing y'all tomorrow. We will see you then. Goodbye. And have a fantastic Monday night, all right? See ya.